Using Oracle Flashback, as a DBA, you're doubtless going to come across situations where users accidentally or perhaps even intentionally delete data in the database, and then somebody, maybe it's a boss, maybe it's the person himself or herself, comes to you hat in hand and asks and sees if you can restore that deleted data. Oracle 11g has a really nice technology called Flashback that we're going to learn about in this nugget. We're not going to learn about the architectural underpinnings of it so much. That is a DBA 1 exam skill, and we deal with undo management to a great degree of depth in that series. Instead, we're going to take it on faith that our database is already configured for Flashback, and I'm going to show you how to use it to restore deleted rows as well as deleted objects. In other words, we'll be working with Flashback Query, where we can examine data from past moments in time, and we'll also look at Flashback Table that allows us to undo entire table drops. Let's get to work. So what is Flashback anyway? Flashback is an Oracle term, it's an Oracle technology that actually is part of only the Enterprise license. Of course, this is the most expensive edition of Oracle Database 11g, and it's worth the money for many businesses. Many businesses will go for the Enterprise license to take advantage of premium features like Flashback. And what this Enterprise Edition only feature does is it enables us to view and restore past states of database objects. So as I mentioned in the opening of this nugget, the most common case is where you have an accidental or inadvertent delete or drop of individual rows within a table or perhaps even entire tables, and you as a DBA are now tasked with leveraging Flashback technology to recover that data. Fortunately, it's pretty darned easy to do. Of course, another reason why Flashback is useful, hopefully you'll see this less often than the first case of accidental deletions and accidental drops, there's the notion of malicious damage. You could have a malicious user either from inside or outside your organization with the intent of destroying data, and then depending upon how robust your undo management is, we can leverage Flashback to bring that data back in lieu of performing a full restore. The issue of backup and restore, as I alluded to in the opening of this nugget, is a DBA 1 and even DBA 2 exam topic. As a matter of fact, for the Oracle Certified Professional, or OCP certification title, the issue of disaster recovery, that is to say backup and restore, which includes Flashback, comprises a significant percentage of that exam. Just wanted to give you a heads up if you're interested in taking your Oracle certification to the next level. Now, as promised, we're not dealing with the architectural underpinnings of Flashback, but just to get you started if you're interested, what makes Flashback work in Oracle Database is what's called undo data. In particular, Oracle 11g has a feature called Automatic Undo Management, or AUM, that enables you to set a couple initialization parameters and size a table space. I think I told you already that a table space is a logical container for one or more data files, and those data files in turn are what store your data in blocks. And as it happens, undo data stores the previous state of data. We've talked in the past about ACID properties that makes transactional databases transactional, and we've also referenced read consistency, that in order to maintain that consistent state, if a user is currently in a table and making modifications, other users need to be able to get into that same table and not be blocked or locked out of it. Undo data enables us to maintain that read consistency such that users see consistent results. They'll only see the changes that the first user made to the table once that data has been committed. And that issue of the commit is important as we discuss and learn how to use Flashback. Remember that until your work is committed in the database, those changes have not been permanently applied. You could do delete statements all day long, and unless and until you issue a commit, those rows will still exist in the source table. Now, on the other hand, you also know that your DDL statements, of which drop is certainly one, have an implicit commit attached to them, such that as soon as you issue a drop table, as long as you have that associated object privilege, that table is going to be, at least on paper, gone immediately, and that change is considered committed to the database and therefore permanent. I'm going to show you in just just a little while how we can use Flashback Table to undo what could otherwise be a devastating issue. Now, there are levels of this Flashback technology. We have Flashback Query, where we can run select statements as of a particular timestamp or system change number. And this nugget will focus primarily on the timestamp. It takes a little bit of extra work to determine system change numbers. The system change number is sometimes described as Oracle's internal clock. Every single transaction that becomes permanent or committed in the database is assigned a system change number, so it allows Oracle internally to see its consistent data over time. So if you wanted to restore data or view data using select as of an earlier SCN, obviously the first step is to determine what your current SCN is and try to figure out which SCN or SCN range corresponds to the data that you want to go back to. More commonly, we use as of timestamp, where you can pass in a timestamp, that is to say a date and a time where you want to see that data. Now this brings up planning issues. Just to come back to the second bullet point, when you're setting up your undo data, when you're configuring automatic undo management, you need to look at disk storage. You need to think of things like, how big do I need to size my table spaces and data files to accommodate enough undo data? That is to say, it's possible that you or another user who has the Flashback privilege may try to run a Flashback query operation and they'll get the dreaded snapshot too old Aura error. What that means is, because this data in your undo data files is written in a circular fashion, that if your files are sized too small, it's possible for your files to fill up and then be recycled, losing older transactions. I'm just going to touch on this in our upcoming demo in a very brief way. I'm going to take you into Oracle Enterprise Manager and show you where you go in there to configure undo data and to size your undo table space and data files to make sure that your retention is sufficient. Retention is a key word here with undo, and that just simply refers to how many minutes worth of time do you need to keep your undo data. So if we have a retention of 30 minutes and we add a guarantee clause to that, that guarantees that Oracle will not overwrite any transaction changes for at least the 30 minutes. It's going to protect it against overwrite for at least your retention period. That's a planning issue. That's a DBA1 exam concept, but I think it's relevant here to mention. So Flashback Query is a query level tool. We also have the ability to flashback an entire table. This gives us point-in-time table restorations. We can restore the contents and structure of a table to a previous point of time, and we can also, as I've already mentioned, undo the drop table statement as a whole. We're not going to spend much more time here in the whiteboard. I want to take us right into our Oracle server and show you how to start using the Flashback technologies in SQL. The other piece of the puzzle that deals with behind the scenes what's going on with Flashback, AUM or automatic undo management is one piece of the puzzle. The second is the concept of the recycle bin. Now recycle bin, as you know, has been a part of windowing operating systems for many years. Any current version of Microsoft Windows has a recycle bin, as does Linux, as does Mac OS X. It might be called something different, trash instead of recycle bin, but it's the same idea. Well, Oracle 11g database also has a recycle bin, and what this is no surprise, a table located in the data dictionary that stores dropped and deleted objects and data. Specifically, we access the recycle bin to undo dropped tables. That's what we're going to focus on in this nugget. Now, from an SQL command prompt, we can access the recycle bin using our standard data dictionary view prefixes. The user, as long as the user has the ability to flash back objects, can query the user underscore recycle bin. The DBA can query DBA recycle bin, and the difference between the two, obviously, is that the user underscore recycle bin shows only objects that have been deleted by a user and are owned by that user, whereas the DBA has server-wide scope and can see deleted objects from any user of that database, period. Now, I mentioned the Flashback privilege. In order to give some of your users the ability to use Flashback technology, you have to grant them, using the grant statement, the Flashback any table system privilege, or you can use the Flashback object privilege and grant the privilege on a table-by-table basis. But either way, obviously the DBA has these privileges, has all privileges, but if you want to delegate that ability to other users, we can use the grant statements that we learned about earlier in the course. By way way of review, retention for recycle bin is the same thing as your flashback options. It ultimately boils down to your undo management strategy and how you're configuring retention and retention guarantees. The recycle bin can be retrieved from, as we just said, using these views or a graphical tool like SQL Developer. You can also empty the recycle bin using the purge statement if for whatever reason you want to free up that disk space. In this demonstration, we'll work with flashback technology in Oracle 11g. We're looking at our Oracle 19 demo script, and I'm running these actions as the HR user. I like to sprinkle in little SQL Developer tips and tricks as we work through these demonstrations. One I want you to see is that when you've loaded up an SQL file, which you can open from the Open command from the File menu or the toolbar, you can shift the connection context across any of your stored connections by opening up this drop-down list and then just making the appropriate choice. I wanted to mention that. Alright, so to look at flashback query, we do have flashback or undo management enabled for this database. I promised you I'd take you into Oracle Enterprise Manager to show you where that is configured. Here we are logged into OEM, and I've navigated to the Server tab for our database instance. You notice here right in the middle under Database Configuration we have a link for Automatic Undo Management. Let's give that a click. And I haven't changed any defaults. I installed Oracle 11g. I did a fresh install before I started this demo, and I installed the sample schemas and just the ORCL standard database that we've been working with thus far. So what you're seeing are all system defaults. So you see that by default our undo retention gives us 15 minutes of undoability with no retention guarantee. We can change that by clicking the No link. And Oracle by default has given us a table space called undo TBS1 that's sized at 50 megabytes but will automatically extend as it needs to. We can change that table space to a new one or a different one by clicking Change Table Space. Oracle 11g is a self-maintaining and self-optimizing system. Therefore, we have an entire advisory framework where you can ask Oracle for sizing advice based on query load on your systems. And it tells us here some useful information that undo retention is the length of time that undo data is retained. Undo data must be retained for the length of the longest running query, the longest running transaction, etc. That's pretty obvious. We want it to be large enough to be able to roll back in the event of some problem. So we can have it analyze the data and go on from there. Pretty straightforward stuff. Now, let me exit out of Oracle Enterprise Manager and let's come back to our regularly scheduled programming. As HR, I'm going to create a table called Test Table that has two columns. I'm not going to compound complexity by adding in constraints. We don't need to worry about that. I'm just going to create a very plain vanilla table, and then we're going to insert some rows into that table. We already know all about how to create tables and insert if we've been watching the videos, the Nugget videos sequentially. So I'm just going to do a 6-statement insert. And then if we select star from test table, no big surprise here, we can see that data. Now, is this data visible to another user like Scott? Review question there. And the answer, of course, is no, because we haven't yet committed that data. Of course, we can demonstrate that. I'm going to grant select any table to Scott. Not going to be able to do this as HR, so I'll actually cut this statement, switch over to my super user or sys session, paste that in. Now Scott has the ability to query HR test table. So we can run select star from HR test table. We haven't committed any data yet, so we don't see anything. Oracle has found the object. Remember, DDL is committed implicitly, but the DDL, no, it's not. So back to our regularly scheduled programming. Let's issue a commit from the HR side to make these changes permanent. And now on Scott's side, let's rerun our select statement. And of course, we see the same data in both sessions because that data is now permanent in the database. Just for grins, we'll run select count from test table. And as you know, count passing in asterisk gives us the number of rows, which again, we already see. We already know what that is. We're now going to run a delete statement without a where clause. So we know that this is going to delete all rows in test table. We're going to commit that such that now if we run a count from test table, the count is 0. And if we, from Scott's session, try to query that same table, we see nothing. The structure of the table is there, but remember, delete without a where row filter is effectively truncating the table. So here we come into the issue of flashback. Assuming that flashback is enabled, we can use the as of clause of the select statement to look at the data as it existed at a previous time. Now I'm making a note of the clock on my system and it reads 5:48 p.m. So I'm going to let a couple minutes go by, and while that time is going by, let's take a look at my query that I've crafted here on line 43. Now there's always the question when you're accessing flashback data, do you just want to run select as of a previous moment in time, or do you actually want to recover that data and put it somewhere else? I want you to know we can run the select as of timestamp or as of SCN all day long. Now, what might be more helpful, especially in a disaster recovery situation, is that I've just deleted all the rows from test table and I now want to get them back and put them somewhere. I'm going to, in this example, create a table called TT Restore as select star from test table as of timestamp. Does that make sense? So I'm going to create a table using the contents of a previous version, a pre-delete version of test table, and populate that new object in my database. Now you may just want to do a select into test table. I mean, once we have these rows into TT Restore, we can then select back into test table. It's a couple different ways to go. There's never just one solution to resurrect test table as it existed before the database. This is just a good example here that shows how it works. And what we've got going on here is the select star from test table as of timestamp, and then in parentheses you can pass in either an honest to goodness timestamp or you can play around with some system functions. Sysdate is particularly helpful. What this expression does is it takes our current date stamp, time and date actually, and then we subtract 5 minutes. There's 1440 minutes in a day. 5 divided by that gives us sysdate minus 5 minutes. So the current time minus 5 minutes. So the net effect is that this statement is going to create a table from the way test table looked 5 minutes ago. Select these rows and it tells us here that the table TT Restore is created. Now an alternate formulation of this, as I said, instead of invoking system functions like sysdate, is that we can pass in an actual honest to goodness timestamp. So another way to run this query would be to do select star from test table as of timestamp, and then making sure using toTimestamp that what we're specifying is recognized as such. You know how these casting functions work. We talked about these earlier in the course. And then you provide the date and time using, this is traditionally the format, this is the default date and time format used in Oracle: day, month, year, 4-digit year, hour, minutes, seconds. So this statement, if I were to go ahead and use it, which I won't, would create TT Restore from the data of test table as it existed on August 8th at 5 p.m. Does that make sense? So at this point, TT Restore should show up in our connection list. Let me select the table's object here in SQL Developer and click refresh. Sure enough, there's TT Restore. So now we can run select count from TT Restore, and of course the count is 6. We can select star from TT Restore and see the data that we've pulled back to flashback. Good deal. Now then, at this time, friends, let's turn our attention to row level flashback. I've run select star from our TT Restore table, and you see we have 5 rows. I've done some testing in the background. You'll notice that col 1's value 2 is no longer in the list. No matter though. In this case, I'm going to make a single delete from TT Restore where col 2 equals apple, which is obviously row 5 in the results. So we'll make that statement, deleted the row. As a DML statement, we know that it's not permanent unless and until we commit, so let's go ahead and commit. I'll note the time. It's 8:41. So I'm going to run select star from our TT Restore as of the timestamp, August 8th, 2011, 8:40 p.m., where col 2 equals apple. That's what we want to see. So we fetched this row that had been deleted from TT Restore only because that deleted row exists in our undo segment data. To complete this demonstration, let's work with flashback table for a few minutes. First, I'm going to run a drop table against TT Restore to nuke the entire table. You may find when you try to delete tables that have foreign key constraints elsewhere that Oracle will raise an error. I'll show you what I'm talking about. If I run as HR drop table regions, we get SQL error ORA 2449. Unique primary keys in the table are referenced by foreign keys elsewhere. So the option here is you either drop the foreign key constraints in the related tables, or a somewhat, actually not somewhat more destructive, a very much more destructive way to go would be to issue drop table with cascade constraints. I'm going to do that here. The clause means nothing in this case because we know TT-restore has two columns with no constraints attached to them. Remember that with SQL, we're not getting confirmation for stuff like drops. It tells us that the table TT-restore is gone. So if we therefore try to select against the table, we not only get empty columns, we get ORA 942, table or view does not exist. Let me, in our graphical interface, refresh our filtered table list for the HR schema, and you see that TT-restore is in fact gone. Because of flashback, however, we know that the table's not gone, but when you drop a table, it goes into the Oracle recycle bin. Now I can run as the HR user, again to confirm we're logged in as HR, select star from user underscore recycle bin to take a look at the contents of that recycle bin. Now a synonym for user underscore recycle bin is just recycle bin. So we could also run select star from recycle bin to get the same data. To flash back the entire table to before it was dropped, we can run this simple statement, flashback table to before drop. That's going to pluck the deleted object out of the recycle bin and reinstate it. There's some additional stuff you can do with the flashback table statement. You can bring back the table and rename it if for some reason you want to. And or if you're a graphically oriented person and you're using SQL Developer, check this out. In our object list, note that we have a recycle bin. In this case, not only the TT-restore table that I dropped just now, but earlier in my preparation for doing this demo, I dropped a table called test table, so that shows up. So as long as we have undo space available, this can potentially store a lot of information. Now if we select one of those deleted or dropped tables, we can get its data dictionary metadata, tell us exactly when the drop occurred, what system change number is attached to that drop statement, can undrop, can purge. So our actions here are to either purge, which empties the entire recycle bin and would delete or remove our ability to flash back these tables, or we can choose flashback before drop. And remember, as you know, the graphical user interface simply abstracts the SQL code from us. So if we wanted to flash back to another name, instead of TT-restore, we could call it TT-res-restore, just to give it a different name. And if we go to the SQL tab, Oracle tells us exactly what's happening. In this case, flashback table HR dot, and then the name of the table. You'll note that when a dropped table goes into your user recycle bin data dictionary view, the object has a unique identifier that looks like gibberish to us as humans, but certainly is understandable to Oracle. The prefix will always be $bin, and then there'll be a unique identifier for the table. To before drop, and then if you do want to rename it, you could just supply rename to, and then provide the name. I'm going to cancel here because I want to actually execute flashback table in SQL directly. Tells us that the TT-restore is successful. Let me refresh my recycle bin. Still there, unless and until we purge. And to finish this out, let me select star from TT-restore, and sure enough, it gives us our data back. Now that's the data as it existed at the time of the drop. And you'll remember that earlier when we looked at this command here, I wasn't selecting this apple back into the table. I was just verifying that we can pull that deleted row from the flashback area. Therefore, when I dropped the table, it had only 4 rows in it, and naturally, when we restore, only those 4 rows are restored. Now, this is an important comment here. When you flash back a table, your referential constraints are not restored, so you'll still have to go to related tables and reset those foreign keys. Final thing, let me show you how to purge the recycle bin. Let me double left click it. We can right click on any object in the bin, select Purge. The underlying SQL here is Purge Table. I'll apply that. And you notice that the purge is not global, but it's specific to individual dropped tables. Again, I'll right-click, Purge, Apply, and now my recycle bin is in fact empty. Using Oracle Flashback Review. In my experience, Flashback is one of those gee-whiz technologies that can really save your bacon as a DBA and make you look like a hero to your users, to your boss, your customers, or whomever. By now, having worked through the demo and theory of this nugget, you're able to intelligently discuss what Flashback is. You know the basics, the high-level overview of how to configure Flashback in Oracle Database 11g, but most specifically, once those underpinnings have been enabled, you know how to leverage Flashback both at the query and table level to view and restore data from past moments in time. I hope that this has been informative for you, and I'd like to thank you for viewing.